Hey Math 30-2s, today we're going to look at independent and dependent events and the event A intersect B, A and B. First, investigating independent events. One card is drawn from a deck of cards and is replaced. A second card is then drawn. Consider the following events. A, the first card is a heart. B, the second card is a heart. Determine the probability of A. Well, there are 13 hearts in the deck out of 52, which is 1/4. We replace the card and then draw a second card, which is also a heart. So the probability of B is also 13 out of 52, or 1/4. The probability of event B does not depend on whether or not event A has occurred because we replaced the card. Events A and B are said to be called independent events. Independent events are two events that if the knowledge of one event has occurred has no effect on the probability of the other one occurring, we call them independent. All right? Dependent events. Let's say one card is drawn from a deck of cards and is not replaced. A second card is then drawn. Consider the following events. The first card is a heart. The second card is a heart. Determine the probability of A, the first card being drawn as a heart. Well, there are 13 hearts out of 52, or 1/4. Why is it not possible to determine the probability of event B? Well, the first card could be a heart, or it might not be a heart. Depending on whether a heart's drawn or not, will determine whether the second card drawn will have 12 hearts to choose from or 13. We know the denominator will be 51 cards because one card is drawn, but we're not sure if this is going to be 12 or 13 up here because we're not sure if the first card drawn was a heart. So it depends on what happens with the first card. So these are said to be called dependent events. The probability of event B depends on whether or not event A occurs. So two events are dependent if the knowledge that one event has occurred changes the probability of the other event occurring. Classify the following events as dependent or independent. So read through those, classify them, pause it, and then start it up and we'll see what we get. So A should be independent, B should be dependent, and C should be independent. If you're not sure why, you can ask in class tomorrow. All right, next page. Conditional probability. Consider the scenario from the previous page. One card is drawn from a deck of cards and is not replaced. A second card is then drawn. Consider the following events. The first card is a heart. The second card is a heart. We said the probability of A, the first card being a heart, is 1/4. But probability of B depends on whether or not event A has occurred. So we denote the probability of B given A has occurred as conditional probability. So it's read as event B given that event A has occurred. That's what this means. Probability of event B given event A has occurred. In this example, the probability of B given that event A occurs, well, if event A has occurred, there are now only 12 hearts left out of 51 cards. So event A occurring, a heart was drawn. All right. We denote the probability of B given that event A has not occurred. That's what this states. The conditional probability of this event B given that event A has not occurred. So what's that probability? Well, if event A has not occurred, there are still 13 hearts in the deck, but one card was drawn, so we're down to 51 possible ones. So let's investigate conditional probability. A red die and a blue die are tossed. We filled this chart in the other day. The outcomes are shown in this array. Consider the following two events. The sum of the two dice is 10. The number on each die is the same. List the outcomes for the samples for the following events as subsets of the sample space. So A, the sum of the two dice is 10. So we could have a 4-6. We could have a 5-5. Or we could have a 6-4. Those are the only three ways to get to 10. For B, the number on each die is the same. So you'd have 1-1, 2-2, and so on. 4-4, 5-5, and 6-6. Part 3, A intersect B. Well, the only numbers that are the same and have a sum of 10 are 5-5. All right. So state the following probabilities. Probability of A, a sum of 10. Well, there are 3 outcomes. Out of a possible, you look at our chart, and it's a 6x6 grid, so 3 to 36, which is 1/12. B, part 2, sorry, the probability of event B. Well, we've got 6 items there out of 36, or 1/6. The probability of B given that A has occurred. So what this means is that event A has occurred. So one of these 3 numbers are drawn. Now that we've got those 3, that's event A occurring, what's the probability of getting B, a number that is the same on both dice? Well, the only number that's the same on both dice of those 3 is 5-5, so that's a 1 out of 3 probability. What's the probability of A given B has occurred? So now event B occurred. So dice was drawn, or the number on the dice is the same. And now that we've got that, what's the probability that it's a sum of 10? Well, again, there's only one of those out of the 6, 5 and 5. So 1 out of 6 there. What's the probability of A and B? Well, probability of A and B, there's one element, 5-5, so 1 out of the 36 possible. Part 6, what's the probability of B and A? Well, it's the same thing, 1 out of 36. All right. Verify the following then. Part C. Probability of A and B is probability of A times the probability of B given A has occurred. So the probability of A and B is right there, 1/36, should equal the probability of A, we said that's 1/12, times the probability of B given A has occurred. Probability of B given A has occurred, that's 1/3. So 1/36 equals 1/12 times 1/3, that is true. Let's verify the probability of B and A. Well, the probability of B and A we said is also 1/36. Probability of B is 1/6 multiplied by the probability of A given B has occurred. Well, that's also 1/6. So 1/6 times 1/6 is 1/36. That is also verified. Great. That means at the top of the next page, if the events A and B are dependent, then the probability of A and B, A intersect B, is probability of A times the probability of B given A has occurred. All right. Again, that's a formula on your formula sheet. We just have to know when to use it. So example 2. 2 cards are drawn without replacement. Without replacement. From a standard deck of 52 cards, determine the probability of the following events. Both cards are red. So the probability of red, red. Well, there are 26 red cards out of 52 to draw the first card. Without replacing it, the second card must be 25 out of 51. We need them both to be red. We're saying the first one was red, therefore there's only 25 red cards left. All right, you work that out, you get 25 out of 102. B, the probability that neither card is a club. Probability not club and not club. Well, there are 39 not clubs in the deck out of 52 for the first card to be drawn. And then, if one of those is drawn, there's only 38 non-clubs left out of 51. So 39 out of 52 times 38 out of 51 is 19 out of 34. C, the first card is a king and the second card is a 5. So the probability of a king and then a 5. Well, there are 4 kings in the deck out of 52. And that's not replaced. There's only 51 cards left. And there are still 4 5s in the deck. All right. That gives us 4 out of 663. And D, one of the cards is a king and the other is a 5. So this is probability king 5 or probability 5 king. Doesn't say what order now. This one told us the first card was a king, the second one is a 5. This says one's a king, one's a 5. All right. So if I look at it, we've got the king 5 one already over here. That's 4 to 663. Or means we add. 5 king should be the same thing. Right? Another 4 to 663. Just a different order. But we're going to get the same probability for king 5 or 5 king. If the order doesn't matter, now we're going to add these together. So that's 8 out of 663. All right. Multiplication law for independent events. If the events A and B are independent, then the knowledge that event A has occurred has no effect on the probability that event B occurs. This means that the probability of B given A has occurred is the same as the probability of B. Therefore, we can adapt the above law for independent events. Probability of A and B equals the probability of A times the probability of B. That's only true if the events are independent because of the statement right there. All right. So, example 3, 2 cards are drawn with replacement from a standard deck of 52. Determine the probability of the following events. Probability of both cards being red. So probability of red, red. All right. Well, the first card, 26 out of 52. The next card is, that card is replaced, so you still have 26 red out of 52. So in lowest terms, that is 1/4. Part B, the probability that the first card is a king and the second card is a 5, and they are replaced. Well, there are 4 kings out of 52. Replace that card, and there are 4 5s out of the 52 because we replaced the king. That gives us 1 out of 169. Part C, one of the cards is a king and the other one is a 5. So that's the same one as up above. We could have king 5 or we could have 5 king. So we did the probability for king 5. That's 1 over 169. Or means we add. So we, king 5 and 5 king. We're also going to get another 1 out of 169. So that's 2 out of 169. All right. Great. Important to note, students often confuse the concept of mutually exclusive events with the concept of independent events. These terms do not mean the same thing. All right. Here's why. The concept of mutually exclusive events involves whether or not 2 events can occur at the same time. Can they occur at the same time? That's mutually exclusive. The concept of independent events involves whether or not the occurrence of one event affects the probability of the other event occurring. Not whether they can happen at the same time or not, just does it affect one event's probability after another event's occurred. So if the probability of A is 1/3, the probability is 2/5, and the probability of A or B is 3/5, use appropriate formulas to investigate whether event A and event B are A, mutually exclusive events. So Let's go to your formulas. So from your formula sheet, probability of A union B is probability of A plus the probability of B. That's for mutually exclusive events. Probability of A union B equals probability of A plus the probability of B minus probability of A intersect B. That's for not mutually exclusive events. So green is not mutually exclusive, blue is mutually exclusive. So let's do part A. Let's see if these events are mutually exclusive. Let's substitute the things we know. Probability of A union B is 3/5 minus the probability of A is 1/3. Sorry, that should equal probability of A, which is 1/3, plus the probability of B, which is 2/5. So does 3/5 equal 1/3 plus 2/5? Well, let's work that out. Get a common denominator. Common denominator should be 15. So that's 5/15, and this would be 6/15. So that would be 11/15. Is 3/5 equal to 11/15? No, it is not. So we would say these are not mutually exclusive. Doesn't satisfy the formula, so A and B are not mutually exclusive events. Let's go over to part B. Are they independent events? Well, also in our formula sheet, we're told that the probability of A and B for independent events is probability of A times the probability of B. We're told that, right? So if they are independent, we should know what the probability of A intersect B is. Probability of A is 1/3 times the probability of B is 2/5. So the probability of A intersect B should be 2/15. Now, if that's true, then this formula should also hold up. All right, so let's substitute in that formula. We know the probability of A union B. We've got that. That's 3/5. So 3/5 should equal the probability of A, 1/3, plus the probability of B, 2/5, minus the probability of A intersect B, which we just calculated, 2/15. So let's finish calculating that. All right. So we've got 3/5 equals, we did this already, 1/3 plus 2/5 is 11/15. So this is 11/15 minus 2/15. So we get 3/5 equals 9/15. Well, 3/5 does equal 9/15, so that's true. So because that's true, these events are independent. So yes, they are. So A and B are not mutually exclusive, but they are independent based on our formulas. All right. Last example. On this page, let A and B be events with probability of A is 1/2, probability of B is 1/3. The probability of A intersect B is 1/4. Determine the probability of B given A. So if you go to your formula sheet, we're told that the probability of A intersect B is given by the probability of A times the probability of B given A. So we now want to figure out the probability of B given A. So if I solve for that, the probability of B given A, I divide both sides by the probability of A. So probability of A intersect B divided by the probability of A should give me the probability of B given A has occurred. Well, we're given all those probabilities up here, so let's figure this out. All right. Probability of A intersect B is 1/4. So that's 1/4 divided by the probability of A, which is 1/2. 1/4 divided by 1/2, or if you remember how to do your fractions, that's 1/4 multiplied by the reciprocal of 1/2. So 1/4 times 2, 1/4 times 2, we get 1/2. So 1/2 is the probability of B given that A occurs. All right. Let's look at part B. What's the probability of A given B has occurred? Well, we've really got the same formula here. We just want to rewrite it. So if I take some space, the probability of B intersect A should be the probability of B times the probability of A given that B has occurred. Right? That's right from your formula sheet. We're just substituting different things in. So again, if I want to solve for the probability of A given B, I'm going to divide both sides by the probability of B. So the probability of B intersect A divided by the probability of B should equal the probability of A given B. So we know the probability of B given A is the same as the probability of A given B. Sorry, probability of B intersect A is the same as probability of A intersect B. So that's going to be 1/4 divided by the probability of B, which we're told from up above is 1/3. So 1/4 divided by 1/3, you change division multiplication, multiply by the reciprocal of the divisor, and that gives us 3/4. So that's the probability of A given B. Last one. Probability of A union B. So our formula says the probability of A union B is equal to probability of A times the plus the probability of B minus the probability of A and B. So we know the probability of A, we're told that is 1/2. The probability of B, we're told that is 1/3, minus the probability of A and B, which we're given as 1/4. So 1/2 plus 1/3 minus 1/4, 12ths. So 6/12 add 4/12 minus 3/12, 7/12. All right. Last page. All right, example 6. The probability that Sophia will pass math this semester is 0.7. The probability that she will pass English this semester is 0.9. If these events are independent, determine the probability to the nearest hundredth that she will pass math and English. The events are independent. If they're independent, math and English, the probability of that should be the probability of math times the probability of English. That's the definition of independent events. Math and English. Oops. Math and English. So that's right off your formula sheet. All right. So the probability of math is 0.7. Probability of English, we said, passing that was 0.9. Multiply those together, you get 0.63. They're independent events. Probability of math or English. So math or English, right? Probability of math or English. Well, that's the probability of math plus the probability of English. But could you pass them both? Math and English? Sure, we just said that's possible. So they're not mutually exclusive, so you have to minus the probability of math and English. All right. So probability of math, we just said, is 0.7. The probability of English is 0.9 minus the probability of math and English, which we just calculated to be 0.63. So what's the probability of passing math or English? You work that out, you get 0.97. Pretty good chance to pass one or the other or both. It's probably to pass math but not English. So probability of math and not English. Independent events, that's the probability of math times the probability of not English. So probability of math was 0.7. The probability of not English would be 1 minus 0.9 or 0.1. So that probability is 0.07. All right. And finally, the probability of neither math nor English. Probability of not math nor English. All right, not English. So that's the probability of not math times the probability of not English. So not math is 1 minus 0.7 or 0.3. Not English is 1 minus 0.9 or 0.1. So that probability is 0.03. All right. And finally, example 7. A number is selected from the first 10 natural numbers. Consider the event m, a prime number is chosen, and n, an odd number is chosen. List the sample space and the set of outcomes for the events m, n, m intersect n, and m union n. All right, you do that. Pause this and do that, then come back and have a look. All right, so the sample space listed right here. Probability of a prime number is chosen, that's m, 2, 3, 5, 7. An odd number is chosen, that's n, 1, 3, 5, 7, 9. M intersect n, which ones are common? 3, 5, and 7. M union n, put them all together, 1, 2, 3, 5, 7, 9. Great. Part B, state the probabilities of the events m, n, m union n, and m intersect n. So the probability of m, how many events are in m? 4 out of 10, so that's 2/5. Probability of n, well, there are 5 odd numbers out of the 10, so that's 1/2. Probability of m intersect n, well, there are 3 numbers there, 3, 5, 7 out of the 10. M union n, well, there are 6 out of the 10 there, or 3/5. All right, so if we look at part C, determine P, a prime number is chosen. Given that an odd number is chosen, or probability of m given n's occurred using the appropriate formulas. So you get back to page 149, you've got this formula. We'll just write it in terms of m and n now, but the probability of n intersected with m, and this is for dependent events, is the probability of n times the probability that n has occurred, and we get m. So probability of m given n's occurred. So that's using appropriate formulas, and we want to find m given n has occurred, which is right there. So we know the probability of n given, or n intersect m, that's the same as this one, m intersect n. And we know the probability of n is 1/2 from right there. So we've only got one unknown. So the probability of n intersect m is the same as m intersect n, so that's 3/10. So 3/10 equals probability of n, which is 1/2, times the probability of m given that n has occurred. So you have to divide both sides by 1/2 then. So 3/10 divided by 1/2 will be the probability of m given n, or 3/10 times 2/1. Probability of m given n. So 3/10 times 2/1 is 3/5. All right. Now that makes sense, because if you think about it, set n, if you go back to the top here, set n has 5 elements, and given that n has occurred, that's our 5 elements. We want to choose something from m. Well, which ones aren't already there? All right, that's 3 of them. All right, 3 of these are in set m. All right, 3, 5, 7. 3, 5, 7 also occur in set n, so 3 out of 5. So this is using the formulas. This is just thinking about it. 5 elements in n, and of those 5, 3 occur in m. All right. Let's look at D. Aidan said that a quicker method of returning the answer in C would be to look at the number of odd numbers in the sample space and count how many of these were prime. Do you agree? Yes. That's what we just said there. All right. Determine P an odd number is chosen given that a prime number is chosen. So the probability of N given that M has occurred. So let's do the quicker method that Aidan just talked about. Given that M has occurred, there are 4 prime numbers. And of those, how many are odd? 4 prime numbers. How many of those are odd? 3 of those are odd. All right. 3, 5, and 7. What about the probability of N given M if we use formulas? All right. I think that takes a little longer. So this is the quicker way, but if we look at what we did up here, using formulas, the probability of N given M should be the probability of M intersect N divided by the probability of M. So let's see what that gives us. M intersect N is 3/10. Divided by the probability of M is 2/5. So that's 3/10 divided by 2/5, or 3/10 times 5/2, which would give us 15/20, same as 3/4. So either method you want to do it, we get the correct answer. All right, so you've got this assignment. Get after it.